Hello everyone. Today we will be having a look at two problems of Div 2 round 772. So let's start with the video. First problem was min or sum. This is the first problem, but it was a pretty difficult problem for some, and you can find it in the discussion also. So let's have a look at what they say in the problem. So they say over here that you can replace any element in an array a of I and a of j such that a of I or a of j is equal to x or y. So the two new numbers you choose, which are x and y, their or bitwise or should be equal to the bitwise or of the two numbers you choose. Okay, so that means like if we look at this example over here, the two numbers we choose over here are 1 and 3. So the bitwise or of 1 and 3 is equal to bitwise of 1 and 2. So we can switch them. We can switch 1 and 3 with 1 and 2. And our goal in this is to find the minimum possible sum of the array. Okay, so one thing we understand at looking at this problem, what went through my mind was this will have definitely something to do with the bitwise or. So if we look at the bitwise or, I took up an example of bitwise or. If I do a bitwise or of 0 and 2, then answer is 3. So if I do a bitwise or of 2 and 3, still the answer is 3. If I do a bitwise OR of 1 and 3, still the bitwise answer is 3. So after doing this example only, solving it multiple times, what I found was that if you are doing bitwise OR of all the numbers, it is equivalent. Like you can, since you can switch them, you can as well as just switch these numbers. Like all the numbers in the array, you make them 0, and the last number in the array will be the bitwise OR of all the elements in the uh, array. So you, if you would like to say how we come to this conclusion, how we can prove it, see, if if we take this array only as the example, if one comes, then one will set this bit, the one bit. If 2 will come, that it will set the second bit, 1 0. So now if another element comes that will set the same bit, we can definitely switch these because we are allowed to do one or. And in or, still, since you are allowed to do 1 plus 0 type of thing, so we can switch them. So, and another observation we found out while doing this calculation was, if A or B is done, then it will necessarily always be less than or equal to A plus B. This condition was always holding true. So like if you take an example of an array where you are given 1 and 100, so if 1 and 100 is given, you do an OR, the answer is 101. And if you do an sum, the answer is 101. So that's the maximum value possible. Otherwise, it's always less than the sum. So the answer will always be 0. All the elements in the number except like if length is n, from n to n minus 1 elements will be 0, and the last element will be the OR of all the elements. Just have a let's have a quick look at the code. If you understood this logic, it was nothing great, but understanding this logic took me some time. That's why I'm saying this was this difficult thing. We took it in long. This was another catch because the range of numbers given was big. And then while taking the number only as input, I did answer and like did val with, like, I took the input and I did a bitwise or with the previous answer. And so this answer will at the end of the loop store all the store bitwise or of all the elements in the array. And I gave it, just printed it out, and I got the correct answer for this. Now let's look at the second problem.
Hello everyone, so this is Mankit Singh here. So now we'll look at the second problem. The name of the second problem was avoid local maximums. So you can read the problem here. I will explain you the problem with the example number with this example. You can read the earlier ones and try to understand, as it is a simple thing. But the most important thing that you need to understand here is that they are telling us to remove the local maximums. So as they have given us here, what is a local maximum in this case is that a of I is a local maximum if it is strictly larger than both of its neighbor. So what does that mean is, here you can look at the first value 1. So as it doesn't have a left neighbor, so we can't actually look understand if it's a maximum or no, it will be a maximum or not. So it will not be a local maximum at all. So one thing is very clear is the first element and the last element will not be a local maximum at all. So let's look at this the one here. So as you can see, it is not larger than any of its neighbors, so it is not a local maxima. So what will the local maxima look like? So the 2 here, this is the local maxima as it is greater than both of its neighbor. So now as we will think about how we will solve this problem, the first solution that comes to our mind is, and the naive solution that we all think is, that we can traverse the array and try to solve the problem. And what approach we can use it, like basically if we want to remove this local maxima, so what we will do is either we can change this 2 to 1, so it will not be a local maxima, or we can change this 1 to 2. So it will the condition that is the element should be greater than both its neighbor will become false, so it will not be a local maxima. So the solution I think is better is to change this value 2 into some other value. So as we are going to we can try to solve this given example, and then we will understand what the catch is, why this question isn't as easy as it appears to be. So first thing we are going to say is keep the 1 as it is. We're going to change the 2 to 1, the we change 1 to 1, and this 3. So as 3 is greater than this 1 and is greater than this 2, so it is a local maxima. So we'll change it to so now another thing to keep note here is that to what value we should change it to. So one thing to understand is we should change it to the bigger value of both its neighbor, the the maximum between 2 and 1. As if we are going to keep it the minimum value, then we will create a new local minima. As you can see, in this case 2 is greater than 3, but if we are going to change this 3 to 1, then in some cases this 2 might become a new local maxima. So now we are going to change this 3 to 2, and next we are going to look at this 2. So there's no problem with this, and we are going to now change the value of 3. We are going to change it to 2 1. Again we will change this 1 to this value of, again we are going to change the 2 to 1, and now again 1. So this is the answer we are getting. So the number of changes we have done is equal to, first we have changed this 2, then we have changed this 3 and this 2. So total we have done 4 changes. Cases where we can change a single value and we will able to fix both of the maximas. We will able to take care of both of the maximas. So I'll show that here. इसमें इरेजर कैसे ओपन करा था तो आइकॉन? वो पेन के ऊपर क्लिक कर. अच्छा, मैं लिखना बहुत मुश्किल हो रहा है मेरे को, तो बहुत गंदा आ रहा है. बंद कर दिया. So the thing here was, so let's first thing so now how I we should approach the question. So how I approached the question was, first I'm just going to underline the local maximums that I found in this question. So I'm going to underline 2, I'm going to underline 3, I'm going to underline this 3 and this 2, and then we'll think on our own that how we are solving this problem. We'll not try to think of a solution, just solve the problem. So the most important thing is, we notice that if we change this 2 to some value like 3, then we are able to take care of both of these values together. So instead of changing two values, by just changing one single value, we are able to fix two maximas. So this is something that we need to do. So now we try to figure out how we can understand that which are the values where this can be done. So there is a very simple understanding that if there's a gap of only one element between these two local maximas, then there is something that can be done. And like for example, one we can use we can change this one and help solve our problem. But if the gap is of greater, like for if you have 2 1 1 3, then you can't do anything that will help you with this case. As like for example, no matter what you change, as the distance is too much, you won't be able to gain any more benefits. So this is the only thing that you need to understand here. So the simple approach I use was that I'm going to traverse the array. I'm going to traverse the array, and I'm not going to look at the first element, as I'm not going to change it, and I'm not going to look at the last element also. So you can traverse it for, so we can traverse the array till the second last element. And as we start from 2, for each element we'll check a simple thing. For example, like we have 2, that is this 2 greater than its neighbors? If it's yes, then we are going to do one simple thing. We are going to take max of this 2 and this 3 here. As we are going to take the max of this, we are going to take care of both of these both of these maximas. As when we change this value of 1 to 3, as we change this value of 1 to 3, we are taking care of both of the maximas. So in this way we can easily solve the problem. I'm going to share the code with you too, so you can look at that and you will be easily able to solve the problem. Here is the code. So let's look at the logic. So this is the for loop that is doing our entire thing. So in this for loop, we are traversing the array from the second value to the second last value. So what is the condition that I have put? It is that if a of I, that is the element we are looking at, is greater than its left element and is greater than its right element, then it is a local maxima. Now there are two things that you can do. And the first thing is we need to check if I plus 2 is less than n. Why we are doing this? We are doing this to avoid out of bound error. We will get out of bound error when is something that you might be wondering, like if you are on the last value, the second last value, that is the so when you're on the second last value, you will get the out of bound error. So to prevent that, we have done this. And in case I plus 2 is greater than n, then we are just have to set a of I plus 1 to max of a of I and a of I plus 1. So this is a very simple logic once you have understood what we are doing. And we have a variable change which calculates the number of changes we are doing. And at the end, we are just giving the output. So hope this helps you. Thank you.